Hi there. Today's bit of work is on linking our speed time graph, which will be measured in ms-1, to a distance time graph, which will be measured in meters. You can see I've set up my two graphs. They've both got the same time scale, and they're also set up vertically below each other so that you can link between here and here. They're both going to be measured in seconds. And we'll start off with section A. So this here shows that it started at 0 meters per second and ended up at 1. And it took 5 seconds to do that. So we've got to find the area under the triangle, which is the half base times height. And this one works out to be 2.5 is the distance there. For the next section, it's a square. So it's just going to be the difference here, which is 5 times 1. So therefore you get 5. This one here is a scenario where you've got a square, which gives us 5 meters covered, and you've got to add to it the fact that we've got the triangle here, which gives it a further half base times height here, and that gives it a further 5. So therefore, it's going to be another 5 up there, and that gives us 10. You might be able to spot that this little bit here could be used to fill in this spot here. So it's really just 2 squares of 5. Okay, on to section D. This is the big section, huge rectangle, and that's going to be difference here. 25 minus 15 is 10 times 3, so it's 30. And then on to E, where it's doing a deceleration here. So that was constant speed. Now we're decelerating back to stop, and that gives us an extra bit of, so we've got to go 2.5, so 30, the bottom is 2.5, which is 30 minus 25 times a half, so 2.5 times 3, which gives us 7.5, just there. Now we've got to fill out the cumulative distance, so that's when we're adding it up. How far is he getting from the very start? So in the first section he did 2.5, so now he's 2.5 from the start. For the next section, he did a further 5, and you add that onto the 2.5. So he's now 7.5 meters into his journey. Section C is another 10, so that gets us to 17.5. And D is the big 30, so that gets us to 47.5. And then this triangle gets us another 7.5, which takes us to 55 meters traveled. Those are both in meters. Now it's time to come down and plot it on our distance time graph. So the first section, he's done 2.5. You can see my scale here is going to allow us to go all the way up to the 55, which will be over here somewhere. So 5 seconds, it had done 2.5. So that's it there. And the next one, it's gone now 7.5. So that gets us up to here, a bit under the 10. Then we go to 17.5, which is over there. Then we've got the big section here. And at 25 seconds, it was all the way up to 47.5, which is over here. And then we add on that last bit, which takes us all the way up to 55, which is up there. You then need to link them with a ruler. And I've got my flexi ruler, and it can help by giving some curves. The curves are just reflecting the fact that the velocity wasn't changing instantly, even though the graph above did show that. And that is it. Whoops, slight amendment here. You can see that it should curve like that because the gradient on the distance time graph will decrease as the speed slows down. And because he's at 0 now, that line, if he stayed at 0, that line would now carry on horizontally because distance is not increasing. So by putting the curve there, it just sets you up, gets your gradient to match your data.